So what we want to look at now is a phenomena that you've probably experienced before in your life, most likely. So, in the wintertime, let's say, you have your, oh gosh, I'll do my that. Let me start over here. In the wintertime, you have your car here, and your car has, like windows and glass and stuff, and windshield, and it's got tires, hopefully. So, in the winter, it can be really, really cold outside. And, the sun will be outside, and the sun will be out in the winter, and the air temperature, let's say outside is, I don't know, 40 degrees. And then you get inside your car, and the inside of your car is really warm. Because the sun here, Mr. Sun, is shining down on your car. Now what happens is, since we're talking about radiation, what happens is the radiation that comes off the sun and hits your car has a certain wavelength. And so what happens is the wavelength of the radiation is a certain wavelength that can go through the glass. So you can imagine you have your glass window in your car, the windshield or your windows, and the radiation from the sun can pass through. It can go through your window. Now what happens is this radiation that comes through gets absorbed by the seeds and whatever, and we said that everything absorbs and emits. But the radiation that the car seat re-emits is a different wavelength, a different frequency. And that frequency cannot go through. It gets reflected by the glass. And so what happens is your car's sitting out there in the sun, it's heating up, and it's absorbing the radiation from the sun, re-releasing that. The heat energy released gets reflected by the glass and gets trapped inside the car. Or what's even worse is on a summer day, you open your car door and there's that just awful blasted heat when you open the car door, and you have to let your car, the insides cool down because it's too hot to get in. What's really miserable is they used to use plastic on car seats, and you couldn't wear shorts because you'd be afraid your legs would melt into the plastic. But the idea is you have the radiation wavelength from the sun, or the frequency, is able to pass through the glass. The interior of the car is absorbing, but it also emits. And when it emits radiation, it's emitting it at a different wavelength or frequency that cannot penetrate back out, and it gets reflected. Of course, this process that goes on in your car, we take advantage of this all the time in something called a greenhouse, right? So a greenhouse works upon this very principle. So a greenhouse, essentially, what does a greenhouse do? It allows the sun's rays to penetrate in. The plants inside, they have little plants, right? Plants are inside. They absorb the photons energy from the sun. They re-emit at a frequency that can't penetrate the glass, and the greenhouse starts to warm up. And that's why greenhouses, you can use them in any climate, even up in the cold north or whatever, because they can just keep absorbing energy and re-radiating it, and so they stay nice and warm even in rough environments. This process that occurs in your cars and in man-made structures like greenhouses is actually one of the things that people are always worried about with the global warming issue, right? So what happens? So here on the surface of the Earth, and up here we have, let's say, the atmosphere. This is our atmosphere. And the atmosphere will allow the sun's shorter frequency to come down, and it hits the earth, and the earth warms up. Now what happens is, we said that the earth will radiate energy. So the earth is going to re-radiate some terrestrial energy. But it's re-radiating this longer wavelength. And that longer wavelength hits the atmosphere, and it gets reflected back. So what happens is the sun's radiating us with energy of a certain wavelength. It comes through our atmosphere, the earth warms up, it radiates, because everything that is above absolute zero radiates. It radiates a different frequency or wavelength that can't penetrate the atmosphere. So this energy bounces off the atmosphere and gets re-radiated back towards the earth absorbs it, and so the idea is that we're trapping extra heat underneath our atmosphere. Now it turns out that the gas that they're most worried about up there that's re-radiating this energy is the CO2. And the interesting thing is that CO2 isn't the worst one. Actually, water vapor is just as bad, but we're not changing the vapor levels in the atmosphere. We've been dumping CO2 into the atmosphere through the burning of our fossil fuels. But CO2 isn't just this thing for heating up the earth. It also does other problems for us when we have this extra CO2. Like when you have extra CO2, it gets forced into the water, causing bodies of water to become slightly more acidic, because CO2 becomes carbonic, becomes like an acid when dissolved in water. That's why soda is slightly acidic, because they're forcing CO2 into the soda. Now it's not like deadly, but to some life form in the ocean, that extra bit of acidity might offset some chemistry that it needs for the organism in the water to survive. You kill off some little organism, some organism in the water that other stuff in the ocean eats, and you can slightly throw off an ecosystem. So just know that this is actually, though, the thing that, part of the reason that people get worried about our levels of CO2 and global warming and stuff is because of this, what they call greenhouse gas effect. One place in the solar system that you can really see that this went crazy, and one of the reasons people do get kind of worried about this, is you look at Venus. Venus is believed to have started off very similar to Earth, because it's a similar planet size to Earth. Venus is believed to used to have water, and what happened is Venus had this process occur. It boiled through the overheating. It boiled off its oceans. Its oceans get trapped up in the atmosphere. Then the atmosphere keeps trapping more and more heat, and its atmospheric pressure goes up because it keeps trapping more moisture up into the atmosphere. That atmosphere then picks up other stuff, and it starts raining like acids and stuff because it's picking up all this stuff into the moisture level, and it's dissolving other things into the atmosphere because of the high pressure. And it's like Venus is like this runaway greenhouse effect, where it's like raining acid and the pressure is just deadly, where it's really high. So this is kind of the fear of the greenhouse effect on